So Kubernetes is actually a container orchestration platform. Means actually when we run the Docker containers, we will be just running one container. So in case if we want to use it in production, like multiple containers has to be run, right? So we are using this Kubernetes. So Kubernetes is a container orchestration tool. Let's see example. So for example, when we do docker run, we will be running a container. Okay, so this will be running. So in case if it stops due to some error or something, then unless for example, if we have an admin, okay, he has to come and then he has to start it manually. Like again he has to do docker run and then -d and then he has to give the pod name. Okay, so it will again come into running state. Otherwise, unless if it is not started manually, it will not run. So for example, if you have an application, it will not be running unless it is manually started. That is the disadvantage of Docker containers. So how to overcome this one? So we got Kubernetes. So Kubernetes is an container container orchestration orchestration tool. So what it does, so it will be running these containers inside a pod. Okay, so it will be running these containers inside a pod. So in Kubernetes we will call this pod. Okay, so it will have containers. So what happens in case if this is stopped due to some error, then Kubernetes will automatically try to bring this up. Okay, so this automatic scheduling of pod is taken care by Kubernetes. That is the main advantage. So we will have the application continuously running without any interruptions. Um, let's see the Kubernetes architecture. So if you take Kubernetes architecture, so actually if you see here, so Kubernetes will have one called control plane, and we will have data plane. So we have something called control plane. Okay, control plane is nothing but master. And then one more thing, like this Kubernetes, it will work on a master slave architecture. Okay, master slave means actually we will have master and then we will have slave. So it is just like normal master and slaves. Like the master will instruct like what has to be done, so slave will perform those tasks. So master will have few components. Those components will be managing all these slave clusters. Okay, so we will have number of slave clusters, like worker nodes, any number of worker nodes we can have. And then we can have like master nodes as well, like multiple master nodes, but in the odd numbers. Because in case if one in case of if Quora voting or something needs to be done, then actually we should have three numbers. For example, if we have to elect two guys who is winning, we have to have three members. When two members vote to one and one guy is voting for two, then one will be the master. Similarly, in case if you have multiple masters, it should be in odd numbers. Okay, and similarly, slaves are nothing but these parts will be running in these slaves, and it will be like managed by master. Okay, so if we take here, so we have two types of things. One is called data plane and another is control plane. Control plane is the master, and then data plane is the worker node. So control plane has four components. Okay, one is API server, that is kube API server, and then etcd. Etcd is nothing but database, and then we have something called kube controller manager, and then we have something called kube-scheduler. Okay, so this is called control plane. Okay, and then this is data plane. Okay, so we have something called API. We have something called API server, and then we have something called scheduler, and then we have something called controller, and then we have something called etcd. Okay, and then we have something called data plane. So what components will be here? Here we will have kubelet. Okay, kubelet, kube proxy, and then we will have container runtime environment. Okay, so this is the Kubernetes architecture. Okay, so actually Kubernetes we will write as K8s as well, because if you see here, okay, it starts with K and ends with S, and in between we have 8 characters, 1, 2, 3, 4, 5, 6, 7, 8. So normally they will sometimes they will refer as K8s, that is Kubernetes only, nothing to be confused. Just as a short form of Kubernetes, they write it as K8s. Okay, and then let's see what exactly this control plane does. So control plane as API. Okay, this is this will be installed on a server. Okay, so this will be installed on a server, and this will be installed on a another server. Okay, so how we can talk with this server? Like in case if you have to talk with this server, we have something called kubectl, kubectl or kubectl. Okay, you can call however you want. Kubectl, kubectl is nothing but a, it is a tool. What tool? It is a CLI, command line interface. It is a command line interface tool. So whenever in case if we are to communicate with control plane, we have to use kubectl. Using kubectl, we will be able to talk. Will we be able to talk to all components? No. In case if you want to talk to this control plane, you will be able to talk only with the API. Okay, you cannot talk with any other thing. So only you can contact API. Okay, and what API does, for example, you want to get some data. Okay, like pods data. If you want to get some pods data, you have to do kubectl get pods, and then it will go to the request will go to API server, and then API server will send to etcd. Okay, what is etcd? Etcd is nothing but a database. Okay, it is like a database. Okay, so what data will this etcd have? It will have data about this API requests. It will have data about scheduler. It will have data about controller. It will have data about kubelet. It will have data about kube proxy. It will have data about container runtime environment. Like in case if you want to get any data of this Kubernetes cluster, you can get those data only from etcd. Okay, etcd will have all the datas. Okay, so etcd will act as a database. So this database will have details of everything. Like you will have data of controller, scheduler, API, kubelet, whatever. In case whatever data you want, okay, all data will be available only in the etcd. Okay, and then this kubectl. Okay, um, you consider this as a person. Okay, this person wants some data, like he wants some address. Okay, so he has to go to API, and API will check some database. Okay, that database etcd, and then whatever information you want, like what is the name of this data plane, or else what you need some data from this data plane, some details about kubelet and some networking details, then you will get from kube proxy. Kube proxy will go for API, and API will fetch from etcd, and it will give to kubectl. So it will have all the details. Okay. Mm, so um, kubectl is requesting some data. Okay, now um, okay, so kubectl will be contacting API, and then API it has to create a pod. Okay, let's consider kubectl has to create a pod. Okay, so if it has to create a pod, it will send the data to API. Okay, like to create the pod. What API will do? API will check whether any of the pod is in the same name or not. In case if it is not there, then it will tell the scheduler. Okay, what this scheduler will do? the scheduler will schedule the pod. Okay, this kubectl is telling to create the pod, and then the request goes to API, and API talks with scheduler. Okay, we have got a request for scheduling the pod, just go and create. Okay, then what this scheduler will do, this scheduler will inform the kubelet. Okay, and then this kubelet will take care of deploying the pods. Okay, so this is acting as a servant. Kubelet is a servant of scheduler, and then scheduler, just like we can consider it as a slave of API, but it's not a slave. It is a component of control plane. We can consider like that because API informs scheduler, and then scheduler contacts kubelet, and kubelet deploys the pod. Okay, and then controller, like we will have multiple controllers, we will have replication set controller, and then if you see here, we have different types of controller, like node controller. In case if you have multiple nodes, okay, and we can call this data planes as node as well. Okay, for example, if we have only one node, this is called node 1. Okay, in case we can have multiple nodes as well. Just let's try to understand with one component. Later on we can go with multiple nodes. Okay, multiple nodes and multiple masters as well we can have. And then um, kubeproxy. So what does kubeproxy does? Kubelet kubelet helps in scheduling the pod. Okay, we got like for example, this pod is there, and we have one more pod. Let's consider we have one more pod. uh, how do we know like which pod is running and which pod is which? For example, we are deploying one application like nginx, and then we are deploying some db, and then we are deploying some other application like docker. And then how do we know like in which pod which is running? So that is managed by kubeproxy. So kubeproxy will assign the IP address for each one. For example, if you have one pod, like it will assign 171.1.1.1, and then in case if you have a second pod, it will be 171.1.1.2, and for third pod it will be 171.1.1.3. Okay, and then in case, what is the advantage of Kubernetes? In case if this pod goes down, it will try to bring up this pod again. Okay, in case if it is trying to bring up the pod again, the IP address of this pod, this just got deleted, and it has created a new pod. Okay, what will be the IP address of this one? It will be like 171.1.1.4 or whatever it is. Okay, but it will not be the same. Before it was like 171.1.1.1, right? It will not be same, it will be different. But it was Nginx application, right? How does this applications know it was previously running on 171.1.1.1? How does it know like the IP address has changed to 1.1.4? It is managed by kubeproxy. So kubeproxy will update the services. So those services will have the details of these IP addresses. So what is the main use of kubeproxy? Kubeproxy will assign the IP address. In case if the pod is restarted and it gets a new IP, those IP it will be assigned by kubeproxy. And then we have something called container runtime environment. Okay, so we have containers like where the container runs. The container runs on Docker, right? So container runtime environment is nothing but Docker. Uh, we have like multiple runtime environments else, like we have Podman, and then we have Rocket. So we have different runtime environments, but the most popular one is Docker. So you can just try to understand everything with Docker. So container runtime environment is Docker. So what are the components we have? We have control plane and data plane. Okay, control plane is master. Okay, control plane is master, and data plane is slave. And master has four components. One is API server, one is scheduler, one is kube controller, and then etcd. Okay, so what is API? API is the one which receives the data from outside. Like in case if any application has to communicate, it has to communicate with API, and then API informs the scheduler. In case if any parts has to be created, it will inform the scheduler, and scheduler will contact the kubelet, and kubelet will try to deploy the pod in the node. And then what is the use of controller? Controller will control different controllers, like we have node controller, we have replication set controller, we can see that later. So these controllers are managed by this controller. And what is etcd? Etcd is nothing but database. Okay, and in data plane we have kubelet. Kubelet and kubelet will run as a, so everything like kube proxy, everything will be running as a pod, but kubelet it will run as a service. Okay, so this it will get the instructions from any of the scheduler or any of the component, and then it will schedule the pods. Okay, and then it will manage those pods. And then kube proxy it will be like a networking, so it will be assigning all the IP addresses and those things for the pods. And then we have something called container runtime environment. What is container runtime environment? It is like to run the pods we need some docker containers, a container runtime environment, that is docker. And then it is not mandated to use docker, we have different components like podman and rocket as well, so you can use anything. So this is the Kubernetes architecture. So you can like expect in the interview as well. So the developer, like in the interviewer will ask you to explain the architecture of Kubernetes. So you should tell like Kubernetes is an master slave architecture. So it will have a control plane and data plane. Control plane will have four main components like API and scheduler, kube controller, etcd, and data plane will have kubelet, kube proxy, container runtime environment. So all the requests, like in case if you have to contact the kube controller, we contact it through kubectl. It is a CLI tool. So it will, when we do give any commands, so that will be going to API server. API server will fetch the data from etcd, and then based on the request it will send the information to scheduler in case if it has to create new parts. So based on that, scheduler will send the request, and kubelet will try to deploy the pods. Okay, so you can explain like this. And then now let's see what exactly is pod. Okay, so pod is nothing but the smallest part in Kubernetes cluster. Smallest part in Kubernetes cluster. Okay, so previously we have seen Docker, right? So when we do Docker run, we get the container. Okay, we get the container. So how we run the Docker? So we have to first build a image. Okay, so image, we have to build the image. So when we do Docker run, when we do Docker run, what we get? We get container. Okay, so how many containers we got? We got one container. So when you run this for first time, you get one container. When you run for second time, you will get container 2. Okay, and then when you run for the third time, you will get container 3. So what is the difference between Docker and container? In case if this container goes down, it will not come up until we manually again run the container, like Docker run, and then we have to give the container name. Similarly, it has to be managed manually. So these things are automated using Kubernetes. Like in case if this container goes down, it will try to bring up automatically. So this is container, right? So this is the smallest part. But in this is container is the smallest part in Docker, but in Kubernetes, the smallest part is called pod. Okay, the smallest part is pod. Okay, and then this container runs inside this pod. Okay, so let's consider this as pod. Okay, and we will have the container. Okay, you can have multiple containers as well, C1, C2. Always it is recommended to have only one container, but we can have multiple containers as well, like C1, C2, any number thing. Okay, so we have the pod, and then we have something called deployment. So deployment is nothing but, let's consider this as deployment. So deployment can have multiple parts. Let's consider this as pod. Let's consider as two parts. Like this is pod 1 and this is pod 2. Okay, so inside pod we have C1, C2, C1, C2. Like we can have containers. So you understood, right? So deployment is the bigger part and pod is the smaller part. and inside pod you will be defining the container. Okay, so how the container we get? So container we can get by running the docker image. Okay, so docker is related to this parts. So if you come here, so Kubernetes overview. So Kubernetes is a container orchestration platform for automating deployment and scaling. And then what are the key components? Key components: cluster. Cluster is nothing but so here we have seen this, right? So control plane and data plane. So together it is called as a cluster. Okay, and then we have master node. Master node manages the cluster. Okay, and then we have worker nodes. Worker nodes runs the application. How it runs the application? It has kubelet and it will create multiple parts and it will be running. Okay, and then we have Kubernetes architecture. Kubernetes architecture is that Kubernetes cluster, it will have control plane and worker node, and then control plane components. So what are the control plane components? We will have API server, that is called kube API server. So it acts as the entry point. Okay, it is the entry point for all the administrative tasks. So whichever task you have to do, that is the entry point. Okay, and then what are the features? It serves as the Kubernetes REST API, so that you will be able to connect to this Kubernetes cluster using this API. Okay, and it authenticates and validates the request. So if someone is trying to request, it will check. So we have something called RBAC policies and all. We will see that later. So it will check whether this user is a legitimate user or not. Like in case whoever asks, if it gives the details, some hackers can request the data and they can hack our systems, right? So it will not respond to all the users. It will just try to respond to the users who are authenticated users. Like they have to give their username password while they log in, and then only it will respond. Okay, and then it updates the etcd data store with the cluster decide state. So whatever data it gets, it updates the etcd. And one more thing, guys, main thing is no other component can contact etcd. Okay, this database cannot be accessed by any other component apart from API. Only API can access this etcd. Okay, and the requests can come only to API, and only API can access etcd. Okay, no other component like scheduler or controller cannot access the data of etcd. Okay, so it, in case if for example we are getting a request like to create a pod. Okay, and then API informs scheduler to create the pod. It creates the pod name, let's assume like engine x1. uh, so we have created the pod engine x1. So in case some other guy like from our team comes and does qctl get parts, it will show engine x1 is created. And then how do we get that data? Because the API server will check the etcd. So the API should, once the pod is created, the API should update etcd, like we have created new pod, just to keep the data for your information, like that. So the etcd will be updated with the data, and when some other guys comes and queries the same thing, it etcd will respond and API will respond to that user. Okay, so it updates the etcd data store with the cluster's desired state. And then we have something called cluster store called etcd. So it is a distributed key value store that holds all cluster data, like these whatever data we know about cluster, all those data will be available in the etcd. Okay, and then and if you see here, it ensures um, ensures consistency across the cluster. Like in case if you have multiple nodes, all those data will be available in etcd. And then in case if you have multiple control plane, okay, we have this is control plane 1. In case if you have control plane 2, control plane 3, so it will have like multiple etcd, right? But all etcd servers will have the same data. Okay, and then it is helpful in high availability and fault tolerance. And then, as I said, what is control manager? It runs the multiple controllers and ensure control cluster state matches the desired state. For example, if you request something like we need this number of parts, we request API and scheduler and controller will take care like a particular number is met. For example, if we need like for example we have 3 pods here. For example, if we need 6 pods, okay, then we can update the settings as replica set equal to replicas equal to 6. Then what it happens, we have configured the replicas equal to 6. Then it will update the kubelet to update the replicas to 6, so that it will create 6 pods. Okay, so we can see those things later. Just for now we can know, like this controller will control the replica sets, nodes, everything. And then scheduler will assign the parts to the nodes based on the resource requirement and constraints. Okay, this scheduler will, it is a very intelligent tool. Okay, it will not schedule blindly. For example, if this data plane is having some memory or data constraints. Okay, so for example, it has already deployed 3 parts and it doesn't have additional RAM or memory, then what it does, it will not schedule, it will throw error like we don't have sufficient memory, please increase the number of nodes. Then we have to increase the memory and RAM of this particular data plane, or else we have to create a new data plane and then we have to schedule. Then it will be scheduling the new parts. Okay, and then we have node components. Worker node components are kubelet, kube proxy, and container runtime environment. If see, kubelet is, it acts as agent on each worker node. Okay, so it will be defining the number of parts in the cluster. And then kube proxy is nothing but proxy, means it is network connectivity. So it will enable the connectivity between these different parts. In case if they have to communicate, they should have different IP addresses, right? So is kube proxy assigns the IP addresses for these pods, and then it will assign. And then container runtime environment. So it's responsible for running the containers. In case if you have to run these containers, containers. So if you see here, we have the image, and then we do Docker run. If you want to do Docker run, we should have Docker, right? Without Docker, if we do Docker run, it will not execute. It will tell like Docker runtime environment is not there. So we should have the Docker runtime environment. So that is provided by Docker, and then we have container D, and then we have Cryo, and then we have different tools like Podman, we have Rocket, and then we have different providers. But Docker is the most popular one. Okay. Okay, and if you see Kubernetes objects, okay, we have pods. Okay, this is the smallest deployable unit. Okay, the smallest deployable unit is pod. And then we have something called deployments. So deployment will have the pod. Okay, and then we can set we can set replicas, so that we will know like how many parts should be deployed. And then we have something called stateful sets. What are stateful sets? Stateful sets are like databases. In case if you want to manage any databases, then we have to define that part as stateful set. And then we have something called daemon set. This daemon set will run on each and every node. For example, here we have only one node. So in case if you have multiple nodes, we can use this daemon set in each node, so that in case if you have to monitor these nodes, it will be helpful in deploying the monitoring tools. So we can see those things in future. And then we have something called jobs. So in case if pod is coming up, and if you have to do some task for the only one time, for example, when the pod comes up, we have to run some script. So in case if we have to do something like that, we have to run the jobs. Okay, and then we have something called services. If we have 2 parts or 3 parts, if they have to communicate with each other, we have something called services. Service will help in communicating with each other, because if this part goes down, and then it will get a new IP address. So how this part knows like its IP address changed? It is taken care by services. So proxy assigns the IP address, services take care of the communication. Okay, so yeah, these are the main Kubernetes objects, and then this is the architecture of Kubernetes. Okay, so for practicing, we can use Minikube. So Minikube is a mini version of Kubernetes cluster. So let's quickly create a EC2 instance and tries to install this Minikube and see how it works. Okay.
Minikube will be used in production as well, or only for
No,
testing
just
purposes?
for practice.
Okay.
So let's try to create a EC2 instance. So the minimum requirement is like it should have like 2 cores of CPU and 4 GB of RAM for the Minikube to run. So let's give the name as Minikube. Okay, and then I will select Ubuntu, then I will select Ubuntu 22, confirm changes. Okay, and then this T2 micro, it will not be eligible because it has only 1 GB of RAM, so I will go with medium. Okay, and then key pair, you have to select the key pair, and then security group, I will select the already existing one default, and then launch instance. Okay, so we have this one. So let's try to connect this instance. It will take some time to come up. Sudo apt update. So whenever you do, just do this first. So when we do minikube, so if you see here, so the basic components are like, first we have to have the Docker runtime environment, okay, container runtime environment. So we have to install the Docker, okay. So if we see the documentation, I have already kept, I guess. Okay, yeah, we have the steps to install Docker, okay. Just copy these things. So where did I get this one? Just simply you can come Docker install on Ubuntu. Okay. If you come here, just select this one. So we have here. Okay. So just first copy paste this one, and then next install of Docker. Okay. That's it. Paste, enter. Okay. Now we have to install the Docker. Just copy this one, paste. So the Docker is being installed. Okay. Let's see whether it is okay. Yeah. So Docker is up. So now once Docker is done, let's install Minikube. Install Minikube in Ubuntu. So just you can come here, and then it is very simple to create the cluster. Okay, this is also a Kubernetes cluster, and it is very simple to set up. Okay, just paste this one. S- Linux. Just copy this one, paste. So once this is done, you can do Minikube start. Okay, let's do Minikube start. Okay, so okay, so actually we have created the Docker user, so we have to give the Ubuntu permission. Okay, if you see here, we have the command here itself. So it is just adding the permission, and then it is adding it into the Docker group. Okay, so if you see here, it is downloading Kubernetes. Okay, so it is up and running. It's still downloading, and then we have seen something, right? So if we see here, now Minikube is nothing but this cluster, this thing this thing is called minikube. Okay, but in case if you have to connect to this one, what we need kubectl CLI. Without this one we will not be able to communicate with this one. So it's still creating. So if you see here, it is booting up control plane, okay, and it is configuring the rules, everything. And then if you see here, all the networks, everything, so configuring bridge CNI, and then it is using image as well, minikube image. So if you see here, kubectl not found, okay. If we let's try this one, okay, minikube kubectl get pods, paste, okay. So if you see here, these are the pods which are running, okay. So when I do minikube kubectl get pods, it is working. Let's try kubectl get pods. So if you see here, kubectl is not found. So normally in Kubernetes we will use kubectl command to communicate. Here when we use minikube, this minikube command, so it is not like it is working there. But we have to install kubectl. How to install kubectl? So we have already given the commands. Okay, just copy this one. Okay. Copy. So we are giving the paths for bin paths for that one. Okay. So once this is done, you can check the version. Okay. Now if we check, it will be up and running. So if you see here, we are getting the version. So client version is 1.31.2. Now let's do kubectl get parts. Okay. When we do kubectl, okay, what we are defining? We are telling the kubectl. Okay. We are telling this kubectl to do what task? To do get means, you know, right, English, like get pods, like it will try to get the pod names, okay. So this kubectl will contact API to get the parts. So what it will happen now, this command will go to API, and API will go to etcd, and then it will again return to API, and API will return to kubectl, okay. This process happens within a second. So if we come here, when I do kubectl get parts, so it has given us no resources found in the default namespace. Okay. So it is written like no parts are found. So how this is done? So it looks simple, like we just give kubectl get parts, but the architecture, how it happens, this kubectl goes to API, API goes to etcd, etcd again sends the information to API, like there are no parts, and then this API will give to kubectl, and kubectl will display to us like there are no parts here, okay. And then um, we have something called these things like default parts of cube system, okay. And then we have something called namespaces as well, we can see it later. I will explain you those later. So we have these many namespaces, and then where we have checked in the default, okay. Now let's see cube system, okay. Just copy this one, just do kubectl get pods -n, and then paste that namespace. If you see here, we have these many pods. If you see here, etcd, we talked about this one, right? This is the database. Okay, this is the database, and then we have something called core DNS. DNS is nothing but you know, right, domain naming system. So in case if you have to manage the domains, we use this one, and then we have something called etcd minikube. This is for database, and then we have API server. All this kubectl will connect to this API, and API will go to etcd. Okay, and then we have controller, and then we have kube proxy, and then we have kube-scheduler, and then we have storage provisioner. Okay, so these are the things. Um, if you see here now, the entire Kubernetes cluster is ready. Kubectl get pods. So by default, in case if you're not giving any namespace, it will check the default namespace, and then it will say like nothing is available. So now let's try to run a simple pod. So what we do, kubectl, okay, and then what we tell, run, and then what is the name of the pod, nginx. Okay, we have just like docker. Okay, in docker run hyphen d, and then we will give hyphen hyphen name nginx hyphen hyphen image nginx. Okay, and then if we have to define it in a port, we will give the port number as 8080, right? So we will be giving it at this place, but we will be giving hyphen p 8080. You understood? So in docker we give this one. Okay, we give this one docker run. So instead of docker, what we are using, instead of docker we are using kubectl. Okay, and then run. Here also run, and then nginx. Here we are giving hyphen hyphen name. Here no need of giving name. Okay, you can directly give this one. Even here if you don't give any name, it will automatically take some name. So here you can give name, and then image. Here also we are providing image, and here also we are providing image. And then here with hyphen p we are providing the port number. Here we are giving hyphen hyphen port. Here here also you can give with hyphen p, it will work. Okay, so now let's try to create. Let's just copy this one and paste it here. Okay, so if you see here, pod, previously in docker it will be container, right? So here it will be pod. So now let me do kubectl get pods. So nginx is running. Okay, so in this way we will be defining the pods. Okay, okay guys, that's it.